Hello dear students, welcome back to my channel. Today in this session we are going to discuss about the theorem 4, that is SSS similarity theorem, side similarity theorem. Let us see the statement of this theorem. If in two triangles sides of one triangle are proportional to the sides of other triangle, then their corresponding angles are equal and hence the two triangles are similar. So we need to learn this statement. So you have to learn this statement first, and then the next step is we have to write the data now. So the data is, so as I said in the previous videos, so the first we have to divide the statement into two meaningful parts to get the data and to prove. So first I will read from here. If in two triangles means, so we have two triangles here. You can see these two triangles, that is triangle A, B, C, and another one triangle D, E, F. So I will write here in triangle A, B, C and triangle D, E, F. If in two triangles sides of one triangle are proportional to the sides of other triangle. This is the first part. Sides of one triangle means, that is AB and then BC and AC are the sides of triangle ABC, and DE, EF and DF are the corresponding sides of the triangle DEF to ABC. So that is, they are proportional means the ratio of those three corresponding sides are same, that is AB divided by DE, that is corresponding side for AB is DE, and in the same way the corresponding side for BC is EF. For BC this is EF, and then for AC the corresponding side is DF. I can write AC by DF. This is the data according to the statement, that is the sides of one triangle are proportional to the sides of other triangle. So I have written the corresponding sides in the same ratio. And the next step is to prove. So what we have to prove here now is, so continue the statement here, then their corresponding angles are equal and hence the two triangles are similar, which means we need to prove that the corresponding angles are equal. That is, corresponding angle for A is angle D, and angle for B, angle E is the corresponding angle, and for C angle F is the corresponding angle. So we have to prove angle A is equals to angle D, angle B is equals to angle E, angle C is equals to angle F. So I will write angle A is equals to angle D, and angle B is equals to angle E, and angle C is equals to angle F. This is what we need to prove in this theorem. So the next step we have to know is the construction. So construction is same as that of the last theorem, that is AAA similarity theorem. So in the same way, so that is AB, you have to know the length of AB and you need to measure the length of DP. So, and you have to mark point P on DE, and same as that of AC, you need to mark a point Q from D, which is equals to the length of AC. So, and we have to join P and Q. So we have to write that is AB is equals to DP. The length of DP is as same as that of AB, and AC is equals to DQ. The length of AC is same as that of DQ. So we have to make this construction, and again we have to join from P to Q, which means I have joined here already P to Q. So we will get another one triangle, that is triangle DPQ. So this is the newly formed triangle. So this is the initial stage of this theorem. We will see the next step is proof. So for the proof we need to take the help of data, that is I will take AB by DE. So you can observe the figure here, AB divided by DE and AC divided by DF. We can take only these two things, that is AB by DE is equals to AC divided by DF. This is from data. We have taken this from data. You have to write here it in the bracket from where you got that equation. So you just observe the construction here. So in AB and DP are of same length, AC and DQ are of same length. I can replace AB by DP. That is, in place of AB I can replace DP divided by DE is equals to, in place of AC we can write DQ divided by, the denominator is same as DF. So from where you have replaced these two? This is from construction. From the construction we have replaced AB by DP, AC by DQ. So from the construction we got this statement or this mathematical form. Now just take the reciprocal of this step, that is, so just taking by taking the reciprocal I will get DE divided by DP, which is equals to DF divided by DQ. So by taking reciprocal, we have taken the reciprocal of the above step. So now subtract 1 on both sides. Subtract 1 on both sides of the above equation. So we will get DE divided by DP minus 1, which is equals to DF divided by DQ minus 1. So now take the LCM of this denominators. Here is nothing but 1, here also nothing but 1. So for the LCM of DP and 1 is again the DP itself. So by taking cross multiplication, DE into 1 is again DE minus DP into 1 is DP, which is equals to, again take the LCM of these two, DQ and 1, the LCM of DQ and 1 is again DQ. So take the cross multiplication, DF into 1 is DF minus DQ into 1 is DQ. Now from the figure you can see the figure now. So from the figure we can come to know that is DE minus DP. Observe the figure here, DE minus DP. In total DE, if we remove DP, I remain with PE only. So PE divided by the denominator as it is DP, which is equals to, on this side, DF minus DQ. You can observe the figure here. So DF minus DQ. In DF, if we subtract or if we remove DQ, we will remain with only QF, that is QF divided by DQ. So again taking back the reciprocal, this is from, you can write here, this is from figure. So you can again take back the reciprocal, we remain with DP divided by PE is equals to DQ divided by QF. DQ divided by QF. So just observe the triangle DEF here. So DP divided by PE is equals to DQ divided by QF. You can remember the converse of basic proportionality theorem, that is first theorem. So if a line divides the two sides of a triangle in the same ratio, then that line is parallel to the third side of the triangle, the statement of converse of BPT. by using that converse of BPT, just remember that dP divided by PE is equals to dQ by QF. So which means this P and Q are dividing the sides of triangle DE and DF in the same ratio, which means this line PQ is parallel to EF. So I can write PQ is parallel to EF. So this is from converse of BPT. This is from converse of BPT. By converse of BPT, we can write that is dPQ parallel to EF. Now, see, PQ parallel to EF means angle P and angle Q are corresponding angles, and angle Q and angle F are corresponding angles. So I will say once again, angle P and angle E are corresponding angles. Angle Q and angle F are corresponding angles. As these two lines, that is PQ parallel to EF, these two lines are parallel, the corresponding angles are equal. So by using that principle, I can write angle P is equals to angle E, and angle Q is equals to angle F. Angle Q is equals to angle F. So we can take this as equation number 1. This we can use in the next step. The next step is, see, observe this figure. Angle P is equals to angle E, angle Q is equals to angle F. We proved just now. Angle D is common for both triangle DPQ and triangle DEF. So we can write that is triangle DPQ similar to triangle DEF by AAA similarity criteria. So by AAA similarity criteria, that is this angle is equals to this angle, this Q is equals to F, angle D is equals to angle D itself. So by AAA similarity criteria, that is from previous theorem, we can write triangle DPQ is similar to triangle DEF. If these two triangles, that is triangle DPQ and DEF, are similar, so we can use the definition of similarity, that is, if two triangles are said to be similar, their corresponding sides are in the same ratio. By using that statement, or by that definition, so DPQ is one triangle, DEF is another one triangle, DP and DE are the corresponding sides, DQ and DF are the corresponding sides, PQ and EF are the corresponding sides. That is, I can write DP divided by DE, which is equals to DQ divided by DF, which is equals to PQ divided by EF, the ratio of corresponding sides. So this is from definition of similarity. I have explained it in the previous video. You can go through that. So if two triangles are said to be similar, the corresponding sides must be in the same ratio. So we just proved these two triangles are similar. So I have written the corresponding sides are in the same ratio. So now in the next step, we have to remember the construction. So in the construction, the line DP, the side DP is exactly equal to AB. I can replace DP by AB. The denominator is same as that of as the above, and DQ. So in place of DQ, I can replace AC by construction. So DF as it is. So you write PQ by EF as it is. So from where we have replaced, that means this is from construction. So dP by AB, dQ by AC. So we just replaced from the construction. So we can name this as equation number 2. So I will write the given here. So given is AB divided by DE, which is equals to BC divided by EF, which is equals to AC divided by DF. This is the data. So just compare this equation to one data. I will show here now. AB by DE is equal to AB by DE, same it is. So and the AC by DF is equals to AC by DF. So the just difference thing is PQ by EF is here and BC by EF. So here observe PQ by EF is equals to AC by DF, which is again equals to AB by DE. Here also AC by DF is equals to BC by EF, which is again equals to AB by DE. Here the two factors are same. AB by DE, here also AB by DE. AC by DF, here also AC by DF. So if these two, the things which are equal to the same thing are equal to one another. So by comparing this data and equation 2, by comparing equation 2 and data, so we can write that PQ by EF exactly equals to the BC by EF. Or I can write first this BC by EF is equals to PQ by EF. Here observe the denominator here. Denominator is same on both sides of the equation. So we can neglect this denominators. So we will remain with BC is equals to PQ. You call this as equation number 3. Now we have to observe triangle ABC and a triangle DPQ. So those two are congruent. Sir, how it is congruent means? So you have to think very carefully and observe very carefully here now. So just remember the construction here. We know that AB is equals to DP from the construction, AC is equals to DQ from the construction, and just in that equation 3, BC is equals to PQ. By these three concepts, that is SSS congruency, you have learnt in the 9th standard. So we can write here by construction AB is equals to DP and AC is equals to DQ. These are two by construction, and BC is equals to PQ. This is from equation 3. Here it is. So by SSS congruency we can write triangle ABC. This triangle is congruent to triangle DPQ. This triangle, small triangle ABC is congruent to triangle DPQ. So by SSS congruency rule, by SSS congruency. So by SSS congruency we just proved these two triangles, that is triangle ABC and triangle DPQ are congruent. So if these two triangles are congruent, we can easily write the corresponding angles are equal. That is for angle A is equals to for angle D. That is for angle A, angle D is the corresponding angle, and for angle B, angle P is the corresponding angle, and for angle C, Q is the corresponding angle. So this is by CPCT, because all these three pairs are corresponding angles of these two congruent triangles. So you can name this as equation number 4. Now we need to observe the equation 1 and equation 4. I will show equation 1 here. Here it is. angle P is equals to angle E and angle Q is equals to angle F. Remember this, angle P is equals to angle E and angle Q is equals to angle F. So I will write here, so in the rough column, angle P is equals to angle E and angle Q is equals to angle F. This is equation 2. So now observe equation 4 and equation 2. So just compare those two. So there is no any correlation for A and D between 4 and 2. So just write angle A is equals to angle D directly. Now observe angle B is equals to angle P. It is in the equation 4. And go for equation 2. Angle P is equals to angle E. Here angle B is equals to P. P is equals to E. So likewise, that is angle, if A is equals to B and B is equals to C, then A is equals to C. So we have learnt it from the basics of mathematics. So in the same way, here angle B is equals to P and P is equals to E, which means angle B is equals to angle E. So in the same way, here C is equals to Q and Q is equals to F. So we can write angle C is equals to angle F. So we got these three pairs by comparing equations 2 and 4. By comparing these two equations, we got this. So now the first part of this theorem is completed. That is, you can observe to prove there. So you have to prove the corresponding angles are equal. That is, in the figure I will show you. Angle A is equals to angle D, angle B is equals to angle E, angle C is equals to angle F. This is what we required. And also we have the second part or second point there. We have to prove these two triangles are similar. That is, triangle ABC similar to triangle DEF. I forgot to write that in the second point to prove. You can make it there. So we have to prove triangle ABC similar to triangle DEF. So that is very easy, because by data we know that the corresponding sides are in the same ratio. We can observe the data there. AB by DE, BC by EF, AC by DF we have written in the data. And in the last step, here it is, we can make this as equation number 5. In the equation number 5, corresponding angles are equal. Angle A is equals to D, angle B is equals to E, angle C is equals to F. By these two conditions, we can remember the definition. That is, if two triangles are said to be similar, then their corresponding sides are in the same ratio, that is in the data, and the corresponding angles are said to be equal, or corresponding angles must be equal. It is in the equation 5. We just proved that by data and equation 5 we can satisfy these two satisfies the similarity condition. Therefore we can easily write triangle ABC similar to triangle DEF. Triangle ABC similar to triangle DEF. This is the required thing, hence proved. So dear students, you have to write all these theorems daily at least once. Then you can easily learn these theorems without any effort. I think you are getting my explanation. So if you like my classes, like the video and subscribe to my channel to get the new updates. Thank you.